All right, so everyone's favorite part, vocabulary. Let's get it over with. So the test 3 study guide, talking about some vocabulary. So some things that I kind of wanted to touch on is this first thing, that's normal distribution. So for a normal distribution, and don't feel like you have to write it, I felt like we went through it too fast last time. So maybe like looking at it as I write it will help. Remember, this is just to recap. So normal distribution. Thank you. So for a normal distribution, some things that I wrote. Is the graph is symmetric about the mean. The graph is symmetric about the mean. Remember, the mean is in the middle of our normal curve. And then the tails extend forever in both directions. The tails extend forever in both directions. That was just something vocabulary-wise I wanted to make sure that you remembered. So remember, this is what our normal distribution looks like. In the middle is our mean, and then our tails go on forever in the positive infinity direction and the negative infinity direction. I feel like too, whenever they give you this list, I'll try to put myself in your shoes. Like, there's so much, we talked about normal distribution. So how was it, like, sometimes they don't want definition, they want stuff like this. So that's why I want to take the time to go over just kind of some topics that they hit on. The next thing is for standard normal distribution. My hand is still like messed up, so I like can't really feel it. So I feel like my handwriting's all messed up, but whatever. Standard normal distribution. For that, remember, whenever it's standard, that means that our mean is 0 and our standard deviation is 1. That's just something to remember. Whenever it's standard, our mean is 0 and our standard deviation is 1. Next thing is going to be the z-score. Sometimes they called it the z-value. Remember that what this is, it gives us the distance. Gives the distance between the mean and an observation x in terms of our standard deviation. So if z is 2, for example, that means between our mean and our variable x, that's 2 standard deviations. That's 2 standard deviations. Remember, if it's z, it's standardized, so that's what makes it in terms of our standard deviations. So one more time, our z-score or our z-value gives the distance between the mean and our x-value, our observation, in terms of standard deviation. The next one is continuous variable. A continuous variable is a random variable that can assume any value in one or more intervals. Going back, I believe it was test 1. Continuous means intervals, so it's a variable, so that means it can assume any value, and then continuous means over the intervals. So continuous variable. Next thing is our sampling error. Bless you. Sampling error. Our sampling error is the difference between a sample statistic and its corresponding population parameter. Remember, a sampling error means that it's a sample and actually the data. So the difference would be you would subtract our sample statistic and our corresponding population parameter. So for example, you would subtract our mean minus our X bar. Remember, this is our population mean. And X bar is our sample mean. So that's our sampling error. If there's an error, that means it's the difference. Difference means subtracting. The next thing is the central limit theorem. So for a central limit theorem, remember it's going to be approximately normal. It's going to be approximately normal. If n is 30 or larger. Our central limit theorem tells us it's going to be approximately normal if n is 30 or larger. Last one for this section is a population proportion. Population proportion is the percent in decimal form of the population that possesses a given characteristic. So population proportion means percent. So it's the percent in decimal form of the population that possesses the given characteristic. It's that portion of the population. Then the next thing talked about formulas. Know your formulas. Remember, for our formulas, some kind of key things that we used a lot was our mean of our sampling distribution is just our mean. So mu sub x bar just equals mu. With that being said, our sigma sub x bar is going to be our sigma over the square root of n. Sigma over the square root of n. Likewise, our mean of our population proportion, mean of p hat, mu sub p hat is just our population proportion, it's just our p-value. Likewise, our sampling distribution for our p hat, for our population proportion, is our square root of p times q all over n. All of these are on your formula sheet. These are just ones that you might want to really look at. So here is our mean of the sampling distribution. Here is our standard deviation of the sampling distribution. Likewise, here's our mean of p hat, and then here's our standard deviation of p hat. So all of these are right here on your formula sheet that you do get to use on the test, just kind of reiterating that real quick. Can I go to the next page? So speaking of population and sample, I just wanted to kind of reiterate that for a population, we have our mean, or we have our proportion, our p-value, our mu or p. Remember, our p-value is for our proportions. So whenever you see a fraction or a percentage, that's our p-value. That's how you know whenever you're going to use p. And this corresponds to our sampling statistics. So our mean corresponds to our x bar, so our population mean. And here's our sample mean. Likewise for our population proportion, and then our sample proportion is going to be p hat. So mu corresponds to x bar for our population and sample, and then our p-value corresponds to p hat for population and sample, just to kind of reiterate those symbols. One last thing, our last thing is talking about this miscellaneous items section. So some miscellaneous items, the relationship, this is what's hard for me to kind of remember. So I wanted to make sure to really talk about this. Our relationship between our mu, our mean value, and the shape. Of a distribution. This one's not so bad. So remember, if the mean changes, that means the graph is going to shift left and right. If the mean changes, the position changes. It shifts it left and right. If the mean changes, the position changes, it shifts it left and right. And then likewise, the relationship between our standard deviation sigma and the shape of the distribution So remember the shape of a normal distribution curve. They call it the shape. In my mind, I think more of like the height. How tall the graph is determined by its standard deviation. This is the wording they use. The shape is determined by the standard deviation. So if the standard deviation changes, that means the shape is going to change. They all have that same like curvy shape, but the difference is the height. So how tall the graph is. So the mean tells us the position. The standard deviation tells us the shape. This is the one I was talking about that gets me. So our last thing, I'm going to kind of put a star by it. So for a normal distribution, I think it gets me because it's just wordy. Or normal distribution as the standard deviation decreases, as the standard deviation decreases. So think about it. So standard deviation, or I should say the width. Because if our width gets smaller, that means our height is going to get taller. So if our standard deviation decreases, standard deviation is our width. So if it gets, our width gets smaller, that graph has to go somewhere, so the graph is going to get taller. So the height of the curve increases. So if the standard deviation, which is the width of the graph, decreases as it gets narrower, 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 the graph has to go somewhere. So as it gets narrower, that means the height is going to get taller. The height's going to increase. So that's pretty much all of the vocabulary type stuff. So before we get into actual problems, questions, comments, concerns, how could I help you so far? Just the vocabulary type stuff that I wanted to hit on.
That's the rubber band thing, right?
Yeah, the rubber band thing. So just to see, what's the other talking about? If our graph looks like this, right? As it gets narrower, notice how it has to go somewhere. My graph's going to get taller. Whereas if I get wider, it's going to get like shorter. If you think about a rubber band and how. All right, anything else? All right, if not, let's get to some actual problems. So starting off with number one, I'm just going to kind of roll through it. You should have already done this, so this is just going to be your time to sit back and kind of recap, ask any questions as needed. And kind of bring it full circle. So for the standard normal distribution, find the area within one standard deviation of the mean. So remember, for standard normal, that means that our mean is 0 and our standard deviation is 1. So in our calculator, we're going to do normal CDF. Within 1, so 1 means that our lower limit's going to be -1, our upper limit's going to be +1, in the middle our mean is 0, and our standard deviation is 1. So that word within means plus or minus. So that gives us the +1 for our upper limit and our -1 for our lower limit. So second vars, going down to normal CDF. Our lower limit's -1, our upper limit's +1. It's standard, so our mean is 0, and our standard deviation is 1. Pressing paste, it should look exactly like I have it written out on paper. Pressing enter, there is our answer. 0.68268, which will round up to 0.6827. Now, let me just make one comment. If remember, you can do it on the table or on the calculator. So it's multiple choice. So if there's one where like your rounding might be a little bit off, like it might say 0.6828, like that is close enough, choose that one, because that means they might have did it on the table where you did it on the calculator, or vice versa. There's going to be a little bit of wiggle room there, but they're not going to give you like 0.6827 and then 0.6828 as two different options. So I just wanted to kind of throw that out there. Same thing for the number 2. It says for the standard normal distribution, find the area within 2 standard deviations of the mean. So now we're going to do normal CDF. Our lower limit this time is going to be -2. Our upper limit is going to be +2. Because it's standard, our mean is still 0 and our standard deviation is 1. So again, we're going to go to second vars, which gives us our distributions. We have a continuous distribution because it's over an interval, so we're going to go down to normal CDF. Our lower limit's -2, our upper limit's +2, our mean is 0, and our standard deviation is 1. Going down to paste, it should look the same for everyone, just how it is written on our paper. Pressing enter, there's our answer. So we get 0.95445. 0.95449, which rounds up to 0.9545. Questions on this page before we go to the next page? Stop me if you have a question. If not, I'm going to keep rolling so that way we can get through everything. Number 3, it says find the normal distribution. For the standard normal distribution, find the area within 3 standard deviations of the mean. So same thing, we're going to do normal CDF. Our lower limit's -3 this time, our upper limit's +3. It's standard, so our mean is 0 and our standard deviation is 1. Second bars, normal CDF. Lower limit's -3, upper limit's +3. Our mean is still 0 and our standard deviation is still 1. Pressing paste to look exactly like we see it. Pressing enter, there is our answer, 0.9973. Number 4, for the standard normal distribution, find the area to the left of z equals 1.45. And if you need to draw your little picture, go for it. But we're still going to do normal CDF. Because we're talking about the area to the left, we're talking about the left tail. So our lower limit's going to be -infinity. So I can plug that into my calculator as -99999. We're stopping at z being 1.45. It's standard, so our mean is 0 and our standard deviation is 1. Second bars, normal CDF. Our lower limit's -infinity, so -99999. Our upper limit's 1.45. Our mean is still 0 and our standard deviation is still 1. And we get 0.92647, which will round up to 0.9265. Number 5 says for the standard normal distribution, find the area to the right of z equaling -0.26. So again, normal CDF. To the right, so that means the right tail. So that means my lower limit's going to be -0.26. My upper limit's going to be +infinity, so 99999. My mean is 0 and my standard deviation's 1. Again, if you need to draw your graph to figure out your lower and your upper limits, you do you. So normal CDF, our lower limit's -0.26, our upper limit's 99999, our mean is 0 and our standard deviation is 1. And that will give us our answer 0.60256, which will round up to 0.6026. Number 6 says for the standard normal distribution, find the area between -2.38 and z equaling -1.05. So between the two, so we're still doing normal CDF. Our lower limit's that -2.38. Our upper limit's -1.05. Our mean is 0 and our standard deviation is 1. Second bars, normal CDF. Lower limit's -2.38. Upper limit's -1.05. Our mean is 0 and our standard deviation is 1. Should all look the same. Pressing paste, there's our answer, 0.1382. 0.1382. Same thing for number 7. Find the standard normal distribution. For the standard normal distribution, find the area between 1.82 and z equaling 3.19. Still doing normal CDF. Because we're using our calculator here, all of these are able to be done on our calculator. Our table, remember, only goes up so large. So 3.19 might not be on our table. but because we're doing it on a calculator, it doesn't really matter. Our lower limit is 1.82. Our upper limit's 3.19. Our mean is 0, and our standard deviation is 1. Make sure those numbers are in order because we're going to go from least to greatest. Second bars, normal CDF. Our lower limit's 1.82. Upper limit's 3.19. Mean is 0. Standard deviation is 1. There's our answer, 0.0337. 0.0337. Number 8, for the standard normal distribution, find the area to the right. So our right tail of z equaling 7.24. So normal CDF. Right tail. So if I think of my graph on the right-hand side, a right tail, my lower limit's going to be that 7.24. My upper limit's going to be infinity, so positive 9.9 or 99999. Mean is 0, and our standard deviation is 1. So in my calculator, second bars, going down to normal CDF, my lower limit's that 7.24, upper limit's infinity, so positive 99999. Is 0, standard deviation is 1. So in my calculator, we get 2.56 e to the negative 13th power. That means 2.56 times 10 to the negative 13th power. So it's scientific notation. That e is scientific notation. So it's the same thing as saying 10 to the negative 13th power. So that means I'm going to move my decimal 13 times to the left. So it's going to be a super, super small number. So by the time that I round it, our answer is going to be 0. Our answer is going to be 0. So looking at the next one, number 9, for the standard normal distribution, find the area to the right of z equaling negative 10.66. This is the other extreme. So normal CDF. It says area to the right. So this is telling us if I had a right tail, this is telling us our lower limit, negative 10.66, comma, our upper boundary would be positive infinity, so 99999. Mean is 0, standard deviation is 1. So in our calculator, second bars, going down to normal CDF, our lower limit we said was negative 10.66. Our upper limit's positive infinity, so 99999. Our mean is 0, and our standard deviation is 1. This will tell us that our area is the whole thing, pretty much. So the whole thing is 1. So number 8 is when our area is so small that it's pretty much nothing. It's pretty much 0. Number 9 is our area is so big it's the whole thing. The whole thing is 1. Number 10, for the standard normal distribution, find the area to the left of 5.55. Normal CDF. On the left, so that means our lower boundary is negative infinity, so negative 99999. Our upper boundary is that 5.55. Our mean is 0, and our standard deviation is 1. In our calculator, second bars, normal CDF. Lower limit's negative infinity, so negative 99999. Our upper limit's 5.55. It's still standard, so our mean is still 0, and our standard deviation is still 1. Pressing enter, it looks just like how we have it written. Pressing enter again, we have 0.999, which rounds up to 1. We'll round up. We usually round to 4 decimal places, so rounding is 1, 2, 3, 4. Rounding that fourth 9 will make the whole thing round up to 1. We're almost done with these. For standard normal distribution, find the area to the left of z equaling negative 6.28. So still normal CDF. Area to the left, so that means our lower boundary is negative infinity, so negative 99999. Our upper boundary is negative 6.28. Our mean is 0, and our standard deviation is 1. Second bars, normal CDF, negative 99999 for our lower limit, negative 6.28 for our upper limit. Our mean is 0, and our standard deviation is 1. That will give us 1.7 e to the negative 10, which is the same thing as saying 1.7 times 10 to the negative 10th power. So if I think about moving my decimal 10 times to the left, that's going to give me a really, really small number, 0.00000, which is pretty much going to round to 0. So that is all of those. Number 12 starts something different. So before I go to the next part, questions on 1 through 11. They're all pretty much the same. Number 12 is the opposite. So this time it gives us the area under the standard normal curve. So left of z is 0.1977, and it asks us to work backwards to find z. So because we're working backwards, this is our inverse norm. This is our inverse norm. Remember, for inverse norm, it's going to be second bars going down to inverse norm. Remember, this is where some of our calculators are a little bit different. This is the only thing they're a little bit different. So my calculator gives me the option for left tail, center, and right tail. Some of our calculators don't give us the tail option. So if you don't have the tail option, it always goes area to the left. That is your default. For here, we're talking about area to the left anyways. So it's all going to be the same, no matter what calculator you have. So our area to the left, they tell us, is 0.1977. It says it's standard, so our mean is still 0, and our standard deviation is still 1. And that's area to the left, and it's all the same because we all in our calculator have area to the left. And this will tell us that our z value is negative 0.849, which is 0.85. So negative 0.85. Same thing for number 13. The area under the standard normal curve to the right of z is 0.8888. Find z. So this is where it's different if you have left or right options. We're still doing inverse norm. If you have the option, so second bars, inverse norm. If you have the option like mine for left, right, and center, I can tell it that the area to the right is 0.8888. My mean is 0, my standard deviation is 1, and I can tell it that this is the area to the right. Or if you have the calculator where you don't have the option for left, right, and center, yours would be the inverse norm. I need to tell the calculator the area to the left. So the area to the left is going to be 1 minus 0.8888, which would give us 0.1112. 1 minus 0.8888. This is area to the left, comma 0, comma 1 for our mean and our standard deviation. So either way you do it, you should get the same answer in the end, which would give us our z value of negative 1.22. So either way you put it into your calculator will give you z equaling negative 1.22.
You mean area to the right, right? The 1 minus?
Yeah, so the 1 minus part, that's only if you have if you don't have the option for left or right. So you'd have to put in your calculator in norm 0.1112, and then yours wouldn't give you this option. It would just automatically be area to the left. So if you did area to the left, notice it gives you the same answer.
So you minus it just for the area to the left? Or
Yes.
just for the right?
You only have to do the subtraction part, the 1 minus part, for area to the left, because they give you the area to the right. So you have to find the area to the left. So you have to do that extra step. So if you have a newer calculator like mine, where it gives you the option for left, right, and center, you don't have to do 1 minus. You can just plug it straight into your calculator. But if your calculator does not give you the option for left or right, you have to do this extra step of 1 minus and then plug that into your calculator. You have to find the area to the left. Thank you for asking. But either way, you get the same answer, just one extra step. Let's do the same thing for the next one. So for number 14, it says the area under the standard normal curve from 0 to z is 0.4906 and z is positive. So find z. Find z. So I'm going to draw a picture for this one. So for number 14, here's our little curve. And it says from 0 to z, and z is positive, so here's 0, here's z, that this area is 0.4906. 0.4906. I want the whole area to the left. So I know half of my graph, this would be 0.5. So area to the left in general, and it would be the same for everyone. So to find the area to the left of z is going to be this half, so 0.5, plus from 0 to z, so plus 0.4906. Which,
Tell us if z is negative, right? So
yeah, it'll tell you if z is positive or negative. Here it says z is positive, so I knew it was on the right-hand side.
Okay.
On the next one, it says z is negative, so it'll tell you which
It's
one.
gonna tell us on the text though is what.
Oh, yeah, for sure.
There was one that didn't tell me. I'm sorry.
Yeah, no, if it, let me know if it doesn't tell you, because if it doesn't tell you,
I should have taken a picture of it, but the answer was negative, but I put positive and it kept telling me
it's
wrong.
wrong. Yeah. Yeah, just let me know, because you have, that's kind of an important part to know.
Yeah. Okay.
So yeah, I'll definitely tell you. So 0.5 plus 0.4906 would give you 0.9906. I'm just going to write this over here. So our area to the left is going to be 0.5 plus 0.4906, which would give us 0.9906. So now for everyone in your calculator, you're going to do inverse norm. The area to the left we found was 0.9906. Our mean is 0, our standard deviation is 1, and that was our area to the left. Second bar's inverse norm, 0.9906, and that's area to the left. Mean is 0, standard deviation is 1. And this will tell us that our z value is 2.349, so z is 2.35. 2.35. So same concept for number 15, but 15 is when z is negative. So find the area under the standard normal curve from 0 to z is 0.4678, and z is negative. Find z. I use my picture to help me see, do I add or do I subtract, or how do I find that area to the left? So this is my normal curve. In the middle is my 0. Z is negative, so z is going to be on the left-hand side. So from 0 to z, this is what they give us, is 0.4678. This is what they give us. So I want to find the area to the left of Z. This is what I'm looking for. So our area to the left, this time if I know this whole half is 0.5, but we're taking out this section, I can subtract. So 0.5 minus 0.4678, and this will tell us our area to the left, which is 0.0322. So I use the picture to help me see, do I add 0.5 or do I subtract 0.5? Here, that 0.4678 is part of the half that I'm looking at, so that's why I subtracted it. So for number 15, our area to the left was 0.5 minus 0.4678, which gave us our area to the left of 0.0322. So our inverse norm for everyone, our area to the left is 0.0322. Our mean is 0, our standard deviation is 1, and that's area to the left. Second vars, inverse norm, 0.0322, mean is 0, standard deviation is 1, area to the left. And that will give us our value is negative, which it told us in the problem, 1.489. 1.849, so negative 1.85. Negative 1.85. So shifting gears for number 16. So if you have a question, please stop me. So number 16 says, let X have a normal distribution with a mean of 75 and a standard deviation of 15. So it's no longer standard normal, now it's just normal. So find the Z value that corresponds to X equaling 91. So going to our formula sheet, here's our Z-score formula. Z equals X minus mu all over our standard deviation. So Z equals X minus our mean all over our standard deviation. X is 91 minus our mean is 75. All over our standard deviation, which is 15. So plugging that into our calculator, make sure whenever you do so, you put the top in parentheses. So in parentheses, 91 minus 75 to show that all of that is up top together, divided by 15. And that will give us 1.066, which will round up to 1.07. Same thing for the next one, number 17. Let X have a normal distribution with a mean of 10.45 and a standard deviation of 1.23. Find the Z value that corresponds to 9.77. So if we have our Z value of X equals our mean divided by our standard deviation, our X value is 9.77 minus our mean is 10.45. Divided by our standard deviation, which is 1.23. So plugging that into my calculator, I want to group the top together, so put it in parentheses. So in parentheses, 9.77 minus 10.45 divided by 1.23. And that will give us negative 0.552, so negative 0.55. Number 18 is similar, but it's kind of like the opposite. This time it says, let X have a normal distribution with a mean of 75 and a standard deviation of 15. Now we're going to find the X value that corresponds to Z equaling 2.47. So now I'm looking for X equals. So on my formula sheet, X equals my mean plus my Z value times my standard deviation. So using that formula from my formula sheet. So X equals my mean plus Z times our standard deviation. Our mean is 75 plus Z, which is 2.47, times our standard deviation, which is 15. Plugging this into my calculator just like I see it, 75 plus 2.47 times 15. And that will give us our X value of 112.05. So just plug into the formula that's on your formula sheet. Same thing for 19. Let X have a normal distribution with a mean of 10.45 and a standard deviation of 1.23. Find the X value that corresponds to Z equaling negative 0.84. So our formula is X equals our mean plus Z times our standard deviation. Our mean was 10.45, plus our Z value is negative 0.84, and our standard deviation is 1.23. Plugging this into my calculator just like I see it, 10.45 plus negative 0.84 times 1.23, and we get 9.4168 as our X value. So now we're talking about stuff that's not standard. So taking this and kind of putting it together with stuff that we did earlier. So number 20. So let X be a continuous random variable that follows a normal distribution with a mean of 550 and a standard deviation of 75. So now I have a new mean and standard deviation. It's not 0 and 1 anymore. Find the value of X such that the area to the left of X is 0.250. So we're trying to find X, which is just like we found Z up here. They gave us the area and now we're working backwards. So they gave us the area and now we're working backwards. So our X value is the inverse norm. Inverse norm. They told us the area to the left is 0.250. My mean is 550. My standard deviation is 75, and we're talking about area to the left, so it's the same for everyone. In our calculator, second bars, inverse norm. Our area, they told us, is 0.250. Our mean is 550. Our standard deviation is 75. And for everyone, it's area to the left. And so that means our X value is 4.994, which I believe on the homework was just, or on the answer key was just 499. Yep, they just rounded it to 499. Don't worry about rounding because it's multiple choice, so it'll tell you which one to round to. So number 21, same concept. Let X be the continuous random variable that follows a normal distribution with a mean of 9.74 and a standard deviation of 0.46. Find the X value such that the area to the right is 0.9351. So this time it gives us the area to the right. So we're going to have to do something a little bit different depending on what calculator you have. So we have X equals the inverse norm. If your calculator gives you the option, like mine, to do left or right, you can just put it into our calculator as 0.9351. Our mean is 9.74. Our standard deviation is 0.46. And this is area to the right. Second bars, inverse norm, 0.9351. Our mean is 9.74. Our standard deviation is 0.46. And our area is area to the right, so we have our right tail, which would give us 9.04315, blah, blah, blah. If you don't have the option for left or right, you have to find the area to the left by doing one extra step and doing 1 minus 0.9351. This tells us our area to the left is 0.0649. So inverse norm, 0.0649. And we got that because it was 1 minus 0.9351. Our mean is 9.74. Our standard deviation is 0.46. And this is area to the left. So you wouldn't put area to the left, but just showing you. So second bar's inverse norm. Area to the left is 0.0649. Mean is still 9.74. Standard deviation is still 0.46. And that would be area to the left if you don't have the option for left or right. But if you notice, it gives us the same answer either way. So our x value is 9.04. Keeps on going, so 9.0432. This is one of those that if you use a calculator or a table, it gives you a little bit different answer, but it's still 9.04. Still 9.04. So it gives you enough to be able to pick the correct multiple choice option. So getting into the word problems. So number 22, the pucks used by the National Hockey League for ice hockey must weigh between 5.5 and 6.0 ounces. Suppose the weight of the pucks produced at a factory are normally distributed with a mean of 5.75 ounces and a standard deviation of 0.11 ounce. What percentage of the pucks produced at this factory cannot be used by the National Hockey League? Okay, so a couple different options here. So let's draw a picture. This is number 22. So here's our little picture. In the middle is our mean. Our mean, they told us, was 5.75. And the weight has to be between 5.5 and 6 ounces, 6.0. But it's saying we're looking for what percentage of the pucks cannot be used. So what percentage lie outside of that? So outside, this would be can be used, but on the outsides it cannot be used. So if we find out what's in the middle, we know in the middle is going to be our normal CDF. Let me write it this way. So if I find out what's in the middle, I can do 1 minus to find out whatever's left over on the outside. So if I, just because I want to write it correctly. So we're trying to find 1 minus the probability that x is between 5.5 and 6.0. So that probability is our normal CDF. Our lower limit's 5.5, our upper limit's 6.0, because we're going to try to find the stuff that's in the middle. And then we're going to do 1 minus to find the outside. Our mean, they told us in the problem, was 5.75. And our standard deviation, they told us in the problem, was 0.11. So in my calculator, I can do 1 minus, second bar's normal CDF. My lower limit's 5.5. My upper limit's 6.0. My mean, they told us, was 5.5. And our standard deviation, they told us, was 0.11. So pressing enter, I already put the 1 minus into my calculator, so it looks exactly like I see it. So there is my answer, 0.0230. But remember, it told me that what percentage, it asked for what percentage. So turning this decimal into a percent, moving my decimal 2 places to the right, this would tell me 2.30% cannot be used. And that's my final answer.
So if the problem says cannot be used, you would do 1 minus normal CDF?
Yeah, because in the middle it told us that in between 5.5 and 6 was fine, right? That gives you a little bit of wiggle room. So this can be used, but it asks us in the problem what cannot be used. So cannot be used is everything that's left over. So because it's cannot, that's why we did 1 minus. Thank you for asking. What else for 22? The big thing too is on the test, it's going to be multiple choice. So you'll see the percentages, but I felt like that percentage was just one extra step that don't forget to turn it from a decimal to a percent. So 2.30%. Number 23 says a construction zone on a highway has a posted speed limit of 40 miles per hour. The speeds of vehicles passing through the construction zone are normally distributed with a mean of 46 and a standard deviation of 4 miles per hour. Find the probability that a randomly selected car has a speed greater than 40 miles per hour. So for number 23, we're trying to find the probability that a car, so that X, has a speed that's greater than 48 miles per hour. So here's our nice little picture. In the middle is our mean. They told us that our mean was 46. And we're looking for 48 when X is 48, so somewhere bigger than that. We're saying X is greater than, so everything on the right-hand side. So to find this area, we're going to do normal CDF. Our lower limit's that 48. Our upper limit's going to go on forever to infinity, so 99999. Our mean is 46, and he told me in the problem my standard deviation was 4. So in my calculator, second bars, normal CDF, my lower limit's 48, my upper limit's positive infinity, so 99999. My mean is 46, and my standard deviation is 4. So it should look exactly like we see it written. And there's my answer for number 23, which is 0.38, I'm sorry, 30853. So 0.3085. 0.3085. Stop me, no question. I'm going to keep rolling. Number 24 says, let X denote the time taken to run a road race. Suppose X is approximately normally distributed with a mean of 190 minutes and a standard deviation of 21 minutes. If one runner is selected at random, what is the probability? Remember, probability means our shaded area. That this runner will complete the road race in less than 160 minutes. So, going to 24, what's the probability that this runner, this X value, will complete it in less than 160 minutes? So probability that X is less than 160. So same thing, here's our nice little picture. In the middle is our mean, which they told us in the problem, our mean is 190. So that means 160 is going to be smaller, so on the left-hand side. We're saying that X is less than that, so we're having a left tail. Our tail's going to go on forever towards negative infinity. So just like the previous problem, in order to find this area, we're going to do normal CDF. Bless you. Our lower limit's negative infinity, so negative 99999. Our upper limit's 160. Our mean is 90, and they told us in the problem our standard deviation is 21. So second bars, normal CDF. Our lower limit's negative 99999. Our upper limit's 160. Our mean is 190, and our standard deviation is 21. And there's our area, there's our answer, 0.0766. 0.0766. Number 25. Fast Auto Services provide oil and lube services for cars. It is known that the mean time taken for oil and lube service at this garage is 15 minutes per car, and the standard deviation is 2.4 minutes. The management wants to promote the business by guaranteeing a maximum wait time for its customers. If a customer's car is not serviced within that period, the customer will receive a 50% discount on the charges. The company wants to limit this discount to at most 5% of the customers. What should the maximum guarantee wait time be? Assume that the times taken for oil and lube services for all cars has a normal distribution. So it's asking us to find the maximum wait time. So it's asking us to find our X value. So whenever we're asked to find our X value, we know we're going to do inverse norm. Let me write it so I have more room. So the problem tells us, number 25, the problem tells us that our mean is 15 minutes. Our standard deviation is 2.4. So in the middle is our mean, which is 15. And it's saying that the company wants to limit the discount to at most 5% of the customers. And the customers means their wait time is longer than 15 minutes. So it's saying that this would be our 5%. That's left over. And then this would be 95%. So this is the X value we're trying to find. How many minutes? That's the X value we're trying to find. So we can do area to the left. Area to the left. So if we're looking for X, we know we're going to use inverse norm. If this is 95%, this means this area is 0.95, so 0.95. Our mean is 15, our standard deviation is 2.4, and for everyone, this is area to the left. So this is saying our maximum of 5%. That's why our right tail is 5%. That means our left tail is 1 minus 5%. Remember, 5% is 0.05. So 1 minus 0.05 is that 0.95. So that's how I got that there. So second var's inverse norm. Our area is 0.95. Our mean is 15. Our standard deviation is 2.4. And that's area to the left. And boom, that is our answer. So it's saying it has to be 18.95 minutes or less. So in order to give the discount to only 5%, that means their wait time needs to be less than 18.95 minutes. 2 more for this page. Oh, I put this on the wrong problem. All right, so number 26 says it's known that the life of a calculator manufactured by Calculators Corporation has a normal distribution with a mean of 54 months and a standard deviation of 8 months. What should the warranty period be to replace a malfunctioning calculator if the company does not want to replace more than 1% of the calculator sold? So it's kind of similar to that last one that we did. So number 26. They told us in the problem that our mean is 54 and our standard deviation is 8. So drawing our picture. So in the middle, our mean is 54. It's asking us what our warranty period should be. And if it's warranty, that means that our lifespan is less than 54 months, right? So this time our 1% is going to be the left tail. So that means your calculator is breaking before the warranty period. So that's why it's going to be our left tail. So our left tail here is 1%, which is 0.01. So now we have our x value that we're looking for. So because we're looking for x, it's going to be inverse norm. Our area to the left is 0.01. Our mean is 54, and our standard deviation is 8. It's area to the left for everyone. Second bars, inverse norm, 0.01. Mean is 54, standard deviation is 8, area to the left. And that means our x value is 35.39. And this is the number of months that it should be, that the warranty period should be.
How do you know, like, with the last two problems, if it's on the left or right?
Yeah.
And it's the word problems, that's what's confusing me.
So how do you know whether it's the left or the right? You have to just look at the problem. So this problem's talking about a warranty. So I know if it's a warranty and they don't want to replace the calculators, that means it's breaking before the warranty period. So that's how I knew it was left-tailed. On the previous problem, it said that like your maximum wait time. So that means the wait time would be more than what I'm, so it's just like the context of the problem. So because the wait time would be longer, that's how I knew it was the right tail. Usually I'm trying to think of, I don't want to tell you wrong, but like the warranties are always usually the left tail. And then like wait time and stuff is usually the right tail. Thank you for asking. Anything else? I know that we're like getting over this review, but I'm trying to hurry. The questions that I skip are the ones that you're going to need help on the test. I'm like, I don't want to skip. I'm gonna keep going. I'm getting over it too. I'm going to be honest. All right, 27. According to the central limit theorem, a sample of where x bar is considered to be large if it has at least how many elements? I love this problem. 30. Done. That's it. That's just the definition. So according to central limit theorem, a sample for x bar is considered large if it has at least 30 elements. Ready for the next page? Ready to be done? Mm-hmm. Number 28, for a population, our mean is 62 and our standard deviation is 12. Find the sample size required for the sampling standard deviation equaling 2. So for 28, they tell us that our mean is 62, our standard deviation for our population is 12, and our sampling standard deviation is going to be 2. And it asks us to find what is n. Whenever you're asking to find what is n, always round up no matter what. Always round up to the next number. Sorry. So on our formula sheet, it's asking us to find n equals. So n equals our standard deviation divided by our sampling standard deviation squared. So just plugging it into that formula. So n equals our standard deviation divided by our sampling standard deviation squared. So we have 12 divided by 2 squared, which in our calculator or in our head would give us 36. So 36, number 28. Number 29, it says for the standard deviation of the 2014 gross sales of all corporations is known to be 18.06 billion. Let X bar be the mean of the 2014 gross sales of a sample of corporations. What sample size will produce a standard deviation of X bar equal to 2.15 billion? So just to kind of try to keep this on the same page. The standard deviations of all, so that means our regular standard deviation is 18.06. What sample size, so we're looking for n, we don't know n, will produce a standard deviation of X bar. So our sampling standard deviation of 2.15. So same formula. So X equals our standard deviation divided by our sampling standard deviation squared. So 18.06 divided by 2.15 squared. in our calculator. Oy. That will give us 70.56. Remember talking about finding our n value. So always round up no matter what. So our answer will be 71. Our answer will be 71. Number 30, it says a population has a distribution that's skewed to the left. Indicate in which of the following cases the central limit theorem will be applied to describe the sampling distribution of the sample mean. Remember, in order for the central limit theorem to be applied, our n value has to be greater than or equal to 30. I forgot 3. Greater than or equal to 30. So n being 45. 45 is greater than or equal to 30. So yes, that one applies. So n being 30, 30 is greater than or equal to 30, so yes, that one applies as well. N equaling 23, 23 is not greater than or equal to 30, so this does not apply. N equaling 500, 500 is greater than or equal to 30, so yes, part D does apply. And then n equaling 12, 12 is not greater than or equal to 30, so does not apply. That's it. You're just trying to see is n greater than or equal to 30 because of the central limit theorem. Number 31, it says how many samples of size 15 can one make using the population of 12 elements? So there's, I think I said 12, 20. I'm trying to go so fast. All right, so this is combination. The order doesn't matter, so we're gonna use a combination. So we have 20 things and we're choosing 15. So going back to 20, choosing 15. I think this was test 2. So it's still talking about sampling, so it's still talking about chapter 7, but bringing back a test 2 topic. So remember for this, we're gonna plug in 20, hitting our math button, scrolling over to probabilities. We're going down to our combination. Order does not matter here. It doesn't say anything about order. We're just choosing sample sizes. And we're choosing 15. So 20, choosing 15. Press enter. There's our answer. 15,504. That's it. So number 32. Says determining the sampling error if the sample mean is 82.56 and the corresponding population mean is 75.95. Remember that our sampling error just means you're going to subtract the 2. So it's going to be x bar minus your mean. Your x bar is your sample mean, which is 82.56, minus your population mean, which is 75.95. 82.56 minus 75.95. And that will give us our error of 6.61. That's it, 6.61. Sampling error we talked about on the vocabulary section just means to subtract the 2. Number 33, 2 sampling distributions are created from the sample population data. One sampling distribution is made using a sample size of 75. The other is created, bless you, using a sample size of 100. Which sampling deviation will have a smaller standard deviation and which one will have a taller graph? So we know that our sampling standard deviation is our standard deviation divided by the square root of n. Our standard deviation divided by the square root of n. So since n is 100, the bigger the sample size, 100 versus 75, so 100 is bigger, so I'm dividing by a bigger number, so this fraction will be smaller. Yes or no? So like think about it. If I have like, I don't know, 2. So 2 divided by 75, or if I have 2 divided by 100, 2 divided by 100 is smaller. 0.026 and 0.02. This one's smaller. I didn't do the square root, but you still get the point. So dividing by a bigger number makes my decimal smaller. So n equaling 100. We'll have a smaller standard deviation. Remember we said smaller deviation means it's going to have a taller graph. It's going to be not as wide. It's going to be narrower. So it's going to have a taller graph. Just like we talked about on that first vocabulary stuff. So choose the larger sample size. Questions on that one? That's a little bit more abstract than we're used to. Stop me if you do have a question. Number 34, the living spaces of all humans, I go to sleep. All right, so the living spaces of all homes in a city have a mean of 2,300 square feet and a standard deviation of 500 square feet. Let X bar be the mean living space for a random sample of 25 homes selected from the city. Find the mean and standard deviation of the sampling distribution of X bar. So we know that our mean is the same thing as our sampling distribution mean, which I told us in the problem was 2,300. So that's our first answer. And our sampling standard deviation, we know from our formula sheet, is our population standard deviation divided by the square root of n. Our standard deviation, they told us, was 500 divided by the square root of our sample size, so divided by the square root of 25. So in our calculator, 500 divided by the square root of 25 will give us 100. Done. Number 35, same concept. If our population mean is 65.34, our standard deviation is 3.78, and our n value is 32, calculate our sampling mean and our sampling standard deviation. So we know our sampling mean is the same thing as our population mean, so 65.34. Done, that's it, that's our answer. And we know our sampling standard deviation is our population standard deviation divided by the square root of n. So 3.78 divided by the square root of 32. Which would give us 0.6682159. So 8219. 0.668219. That's just how they rounded it. 0.668219. Number 36. Let X be the continuous random variable that a normal distribution with a mean of 48 and a standard deviation of 8. Assuming the central limit theorem can't be applied, find the probability that the sample mean, which is X bar, for a random sample of 16 is taken from this population will be blank. So the first one says in between 49.6 and 52.2. It's asking us to find the probability. I was looking for the word probability. So probability is to find the shaded area. So our shaded area is going to be our normal CDF, just like we did on the previous problems, like from the get-go, from the start. Our lower boundary for in between 49.6 and 52.2. Our lower boundary is 49.6. Our upper boundary is 52.2. Our mean, they told us in the problem, is 48. Here's what's different, though, is our standard deviation. Remember, our standard deviation is sigma over the square root of n. So we have 8 divided by the square root of n, which is 16. So sigma divided by the square root of n. Because we have a sample, we have to take that extra step on this problem. So second bars, normal CDF. Our lower limit's 49.6, our upper limit's 52.2. Our mean is 48, and our sampling standard deviation is 8 divided by the square root of 16. This will give us 0.19399, so it'll be 1940. 0.1940. More than 45.7, so I know it's going to be a right tail. So normal CDF. And if you need to draw the picture, go for it. But if it's going to be a right tail, that means my lower limit is going to be 45.7. My upper limit is going to be infinity, so 99999. My mean is 48. My standard deviation is going to stay 8 divided by the square root of 16. So second VAR's normal CDF, my lower limit's 45.7. Upper limit's infinity, so 99999. My mean is still 48. My standard deviation is still 8 divided by the square root of 16. And that will give us 0.8749. Last one, it says less than 46.75. So less than means it's going to be a left tail test. So if I were to draw my picture, my normal CDF, my lower limit is going to be negative infinity, so negative 99999. My upper limit is going to be 46.75. My mean is going to be 48. My standard deviation is 8 divided by the square root of 16. Second VAR's normal CDF, my lower limit's negative infinity, so negative 99999. My upper limit's 46.75. My mean is still 48. My standard deviation is still 8 divided by the square root of 16. So there's my answer, 0.26598, so 2660. 2660. Almost done. Please stop me if you have a question. The times that college students spend studying per week have a distribution that's skewed to the right with a mean of 8.4 hours and a standard deviation of 2.7 hours. Find the probability that the mean time spent studying per week for a random sample of 45 students would be between 8 and 9 hours. So because it tells me a sample, I know I have to do the different standard deviation. So it's saying what's the probability that our sample, so X bar, would be between 8 and 9 hours. So 8 is less than X bar is less than 9. X bar has to be between 8 and 9. So we're trying to find the probability. So we're still doing normal CDF. My lower limit's 8. My upper limit's 9. My mean, they told us, was 8.4. My standard deviation, they told us, was 2.7. But because we have a sample, we have to divide it by the square root of n. So divided by the square root of 45. Second VAR's normal CDF. My lower limit's 8. My upper limit's 9. My mean is 8.4. My standard deviation is 2.7 divided by the square root of 45. So whenever you see a sample, you have to go the extra step for your standard deviation. So here, I put in a comma instead of, oh, no, 8. And this should be 9. There we go. 0.7718 is that answer. Almost done. The end is near. Number 38, the amounts of electricity bills for all households in a city have a skewed probability distribution with a mean of $140 and a standard deviation of $30. Find the probability that the mean amount of electric bills for a random sample of 75 households will be less than $144. So we're trying to find the probability that X bar, because we're talking about a sample, is going to be less than 144. Probability, so normal CDF. It's talking about less than, so that means our left tail. So my lower limit's negative infinity, so negative 99999. My upper limit's that 144. My mean, they told me in the problem, was 140. And my standard deviation is going to be 30 divided by the square root of n, because we have a sample, so divided by the square root of 75. Second bars, normal CDF. Lower limit's negative infinity, so negative 99999. My upper limit's 144. My mean is 140. And my standard deviation is 30 divided by the square root of 75. And we have 0.8759. 0.8759. 39. The GPAs of all students enrolled at a large university have a approximately normal distribution with a mean of 3.02 and a standard deviation of 0.29. Find the probability, so we're still doing normal CDF, that the mean GPA of a random sample of 20 students selected from this university is greater than 3.10. So the probability that X bar is greater than 3.10. So we're still doing normal CDF. We're saying it's greater than 3.10. So we have a right tail test. So my lower limit is 310. My upper limit's infinity, so 99999. My mean, they told us in the problem, is 3.02. And the standard deviation, they told me in the problem, was 0.29. We have a sample, so divided by the square root of n, so divided by the square root of 20. Second bars, normal CDF. Lower limit's 3.10, upper limit's infinity, so 99999. My mean is 3.02. My standard deviation 0.29 divided by the square root of 20. And there's our answer, 0.10865, so 0.1087. Number 40. The population of 1,000 students, 604 homeowners, and a sample of 40 subjects selected from this population, 24 homeowners. What are the values of the population and sample proportions, P and P hat respectively? All right, so first looking at our P value. P values for our population. So in the population of 1,000, 640 are homeowners. So for our P value for our population, 640 divided by 1,000. Proportions means a part of a whole. So we're talking about a fraction. Putting that fraction into our calculator would give us 0.64 for our P value. Remember, P values are in decimal form. Our P hat is looking at our sample. It says of a sample of 40, 24 are homeowners. So 24 out of our 40 are homeowners. So in my calculator, 24 out of the 40 are 0.6. So my P hat value is 0.6. That's it. It's just turning the proportion, which is the part of a whole, into a fraction. Put that fraction into your calculator, give us a decimal answer. So for 41, this is the last 41, 42, 43, 44 are all proportion problems. So according to the latest Strata Gallup report, 58%, so because it says percent, I know it's going to be p-values, I know it's a proportion, of U.S. adults choose to pursue a higher education to get a good job. Suppose a random sample of 250 U.S. adults are selected. Determine the mean and the standard deviation of the sampling distribution of p hat. So for 41, it's asking us for our mean of the sampling distribution. So our mu sub p hat. We know mu sub p is the same thing as just our p value. They told us in the problem 58%. So 58% is our p value. So turning this percentage into a decimal would give us 0.58. That is our mean of the sampling distribution. That's it. And then we need to find our sampling standard deviation, which we know from our formula sheet. Our mu sub p hat is just p. And then our sampling standard deviation is the square root of p times q over n. So the square root of p times q over n. So if we know that our p value is 58%, which is 0.58, that means our q value is 1 minus p, so 1 minus 0.58. Which is 0.42. So the square root, p is 0.58, q is 0.42, divided by n, which they told us in the problem, a sample of 250, so n is 250. So the square root of 0.58 times 0.42 divided by 250, that will give us our sampling standard deviation, which is 0.31215. 0.31215. 42. It says, according to the National Institute on Retirement Security, 66% of millennials have nothing saved for retirement. Determine the probability that more than 70% of millennials and a random sample of 500 will have no retirement savings. So let me go, I don't like being squished here, so let me just go to a separate sheet of paper. So for 42, in the problem they told us 66%, so that's gonna be our p-value, which is 66%, which is 0.66. That means our q value is 1 minus p, so 1 minus 0.66. Which is 0.34. 0.34. And they told us that our sample size, a random sample, is 500, so n is 500. We're asked to find the probability that more than, so p hat is going to be greater than 70%, so 0.70. So we're still trying to find our p-value, so it's still going to be normal CDF. We're looking at our left tail, so remember, if you want to think about it as our p-value being 0.66, here's 0.70, and we're saying everything that's greater, so right-hand side going on forever to infinity. Our lower limit's 0.70, our upper limit's infinity, so 99999. Our mean is our p-value, which is 0.66. And our standard deviation is the square root of p, which is 0.66, times q, which is 0.34, divided by n, which is 500. So just plugging that into our calculator, that's it. Second bars, normal CDF, lower limits 0.70, upper limits infinity, so 99999. My p-value, which is our mean, is 0.66. And our standard deviation of our sampling distribution is the square root of 0.66 times 0.34 divided by 500. Pressing paste will just look exactly like we see it, and that will give us our answer of 0.0295. Last two. Questions on 42, because I need to go to another page. So 43 says 17% of U.S. adults believe that healthcare is the nation's most pressing problem. That tells me percent, I know it's talking about p-value. So suppose, let me just go ahead and write that here. So p-value is 17%, which is 0.17, which will tell us that q is 1 minus 0.17. Which is 0.83. Suppose a random sample of 1,500, so our n value is 1,500. U.S. adult is selected. Determine the probability that between 16.5% and 18% of the sample agree that healthcare is the nation's most pressing problem. Let me go to a separate sheet of paper. Last two, stick with me these last two. So 43, just writing down what they gave us. Our p-value is 0.17, our q-value is 0.83, our n-value is 1500. We're trying to find the probability that our p-hat is between 16.5%, so moving decimal places to the left, so 0.165, and 18%, so moving our decimal 2 places to the left, so 0.18. We're talking about probability, so we're still doing normal CDF. Our lower limit's at 0.165. Our upper limit's at 0.18. Our mean is our p-value, which is 0.17. And our standard deviation is the square root of 0.17 times q, which is 0.83, all over our n value, which is 1500. So let's put it into our calculator. Second var's normal CDF, 0.165. Our upper limit's 0.18. Our mean is 0.17. And our standard deviation is the square root of 0.17 times 0.83 divided by 1500. Pressing paste, pressing enter. There's our answer. 0.54565, so 0.5455. We made it to the last one, finally. My hand's barely making it. Number 44. Mong Corporation makes auto batteries. The company claims that 80% of its LL70 batteries are good for 70 months or longer. Assume this claim is true. Let P hat be the proportion in a sample of 100 such batteries that are good for 70 months or longer. What is the probability the sample proportion is less than the population proportion by 0.6 or more? This, I saved the best for last, I feel like. All right, let's write down what they give us. So for number 44, they tell us that it claims at 80%. So our p-value is going to be 80%, which is 0.80. So that means our q value is 1 minus 0.80, which is 0.20. It also tells us the sample is 100, so our n value is 100. And it's saying, what is the probability that the sample proportion, that p hat, is less than the population proportion by 0.6 or more? So it's saying that our population proportion, which is 0.80, and it's less than that 0.6, so minus 0.06. So 0.80 minus 0.06 would give us 0.74. So it's saying it's less than 0.74 or more. So we have our graph. If you want to do your graph, in the middle is your p-value, which is 0.80. Here's 0.74. And we're talking about everything's less than that, so it's going on forever towards negative infinity. So we have normal CDF. Our lower limit is negative infinity, so negative 99999. Our upper limit is 0.74. Our mean is our p-value, which is 0.80. And our standard deviation is the square root of p, which is 0.80, times q, which is 0.20, divided by n, which is 100. So putting this into our calculator, second var's normal CDF, our lower limit is negative infinity, so negative 99999. Our upper limit's 0.74. Our mean is 0.80, and our standard deviation is the square root of 0.80 times our q, which is 0.20, divided by 100. Pressing paste, pressing enter. There's our answer, 0.0668. So, Lord have mercy. That's everything. Questions, last call, comments, concerns, anything on test 3, because we just did all of it together. If not, let me stop recording. You're welcome to go ahead and get on a computer